Day 16, Iris flower classification using decision trees. Let's build a project to classify the iris flower dataset using decision trees. The iris dataset is a well-known dataset in machine learning containing data about the sepal and petal lengths and width of three types of iris flowers: setosa, versicolor, and virginica. We'll train a decision tree classifier to predict the species of the iris flower based on these measurements. If you have never heard of this, I would say just do some research and come back and you'll understand what I'm talking about. So let's start with our project. First, I have created a day16.py file. There's nothing inside it, so we'll start from scratch. So first step is to import the necessary libraries. The libraries that we need in this particular case is import pandas as PD, used for creating and manipulating data in data frames. We are loading iris from sklearn.datasets. So this loads the iris dataset from scikit-learn. Next, the train test split, which splits the dataset into training and test sets. This is from sklearn.model selection. Next, we are getting the decision tree classifier, which implements the decision tree classifier from scikit-learn. And next, we are getting metrics from sklearn. We are going to get plot tree, a function to visualize the trained decision tree. And finally, we'll get matplotlib.pyplot as PLT, which is used to visualize the decision tree. So we have everything that we need. So now let's go ahead and load and display the iris dataset. The first thing that we'll do is loading the iris dataset, where we will say iris equal to load underscore iris brackets, which will load the iris dataset, which includes features like sepal length, sepal width, petal length, and petal width. The target will be, in this particular case, we'll create the data frame first so we can see what it is. So we have df.pd.data frame, which converts the data set into pandas data frame for easier manipulation. And then we're going to say df species equal to iris.target, which adds the species column as a target for our target data set. Next, let's display the first few rows of the data set. So I'm going to say print iris data set, and then I'm going to say print df head, so we see the first few rows and just to understand what we are dealing with. Next is let's split the data set into features x and target y. To do that, I'm going to say x equal to df.drop species axis equal to 1. The features include sepal length, sepal width, petal length, and petal width. Next, y equal to df species. This is the target variable. Species is either setosa, versicolor, or virginica. So next step is we'll split the data set into training and test sets. To do that, we will call that our favorite train test split and pass x, y, test size equal to 0.3 and random state equal to 42. This time I'm going to divide the training and test set into 70 and 30. So 70% for training and 30% for test set. The random state ensures reproducibility. Measuring the same spill occurs every time you run the code. So next step, we're going to train a decision tree classifier. So for that, I'll create a variable classifier and initialize the decision tree classifier here. Next, I'm going to say classifier.fit and pass it xtrain and ytrain. This trains the classifier on the training set. Next, let's make predictions. So let's make predictions on the test set. We can do that by saying ypred equal to classifier.predict and pass it xtest, which predicts the species of the iris flowers in the test set. Next, once we have prediction done, we will evaluate the model. So we will evaluate the model using accuracy, confusion matrix, and classification report. For accuracy, we'll call accuracy underscore score, pass it ytest and ypred, and we'll get accuracy here. Same for confusion matrix, we'll call confusion matrix, pass the same thing, and for classification report, we'll do the same thing. The accuracy score calculates the accuracy of the model, that is the percentage of correct predictions. For confusion matrix, it generates the confusion matrix which shows the number of correct and incorrect predictions for each class. And classification report provides a detailed classification report including precision, recall, and F1 score for each class. So next step, let's go ahead and print it out. 1, 2, 3. So I'm printing out my accuracy and then confusion matrix, and then I'm printing out the classification report. Next, let's visualize the decision tree. So we are going to use the plot, the matplotlib, to set the figure size as 12, 8. We will we create the plot tree called the plot tree function, pass classifier, feature names equal to iris dot feature names, and field equal to true. So what feature names does is the labels the features, which is the sepal length, sepal width. The class names equal to iris target names. This labels the target classes, setosa, versicolor, and virginica. And fill true colors the tree nodes based on the class they predict, providing a visual understanding of the decision process. And finally, let's go and give a title, not finally, but give a title, and finally show the plot. So the title that I've given is Decision Tree for Iris Flower Classification. So now that we are complete with our entire code, let's go and run this code. So I'm going to open terminal and python day16.py, and here you go, our decision tree for iris classification. And you see it's color coded nicely. It says petal width, depending on the size, it will say true or false. So that looks pretty. Let's close that. So that kind of gets you an idea of how you can use the plot tree to plot a nice classifier tree, use and complete your iris flower classification using decision trees. If you have any problems or issues or have any questions about this, let me know and I'll get back to you.